We're reviewing Learning Target 6.5. I can solve problems using the heat flow equation Q equals mc delta T. So let's first start by defining our variables in this particular equation. So the first variable is Q, which stands for heat, and the unit is the joule, named after a scientist that worked extensively with heat and mechanical energy. The next quantity is M, which stands for mass, which is usually kilogram or just plain old gram with the symbol of G. The symbol for joule is J, if you're interested. The next one is C, which stands for specific heat. And the unit for this one is joules per gram times degrees Celsius. So that's a pretty big unit for that one. The last one is delta, little triangle T, which just stands for change in. So that's what the delta, or so what the triangle stands for, delta, and then T stands for temperature. And we should know that T, the unit, is degrees Celsius. So that's what the variables stand for in that equation. Okay, so let's try an example together. The specific heat of aluminum is 0.9 joules per gram times degrees Celsius. How much energy is required to raise the temperature of 10 grams of aluminum from 5 to 35 degrees? So the way I answer this problem is by first defining all my variables. So I know that I'm going to be using the specific heat equation because it's talking about specific heat. So the first thing I'm going to do is list all my variables on the side. So I know I'm going to need a Q, or I'm going to need to find Q. I know that I'm going to need to find a mass, or be given a mass. I know I'm going to be needing to find specific heat. And a temperature, and I don't and a temperature. So for the symbol for changing, I'll just put T down there. So remember that this temperature is change in temperature. I don't have a symbol for delta, but we're gonna have to just remember that. Okay, so there's my, let me get some space in between those guys so I can write. Alright, so there's my variables. So let me define them. So Q. Am I given a Q? Well, let's look into the question. So I'm given the specific heat, so let me start labeling what I'm given. So this one says that the specific heat of aluminum is that, so I know that that's going to be my C. Okay, how much energy is what it's asking me. And I know that Q means heat, but it also means energy. So I'm going to know that that's my energy. I see this, and I know that that's grams. So that's my mass. And I know that this is a change in temperature. So 35 minus 5 is 30 degrees Celsius. And my specific heat was already given to me, so I'm just going to record that. Joules per gram times degree Celsius. I am looking for Q. That's what I'm trying to find. So I'm going to do the work. So I know my equation is Q equals mc delta T. So I'm going to plug in what I know. M is 10 grams. C is 0.90 joules per gram degree Celsius times 30 degrees Celsius. And then I know 10 times 0.9 is just 9. And then I know 9 times 30 is 270. And then if I want to check my units, I just know that the G's cancel out here, and the C's also cancel out, so I'm left with a unit of joules, and just to make sure, that is the unit for Q, so that would be my final answer. Okay, so now I'd like you to work on an individual example. The individual example says this. A 275 gram sample of a metal undergoes a temperature change from 20 to 50 after absorbing 1500 joules of heat. What is the specific heat of the metal? So I'd like you to solve this on your own and then check your answer with mine. Okay, so the first thing I need to do again is define my variables. So Q is going to be one of them. M is going to be one of them. C is one of my variables. And T. So there are my variables. I'm going to set them over here and I'm going to start defining them. First one I come to in the question is 275 grams. Gram I know is a mass, so I'm going to write that right here, 275 grams. The next one I come is my 20 to 50 degrees temperature change. So if I go from 20 to 50, that's a change of 30. So I'm going to write that right there. And the last number I come to is 1500 joules of heat, which I know is my Q. So I am looking for C. My equation, Q equals mc delta T, can be rearranged to be solved for C, and the way I would do that would be by dividing out m and delta T. Remember, delta T is just a variable like x. You need to do that to both sides. So I'm left with Q over m delta T. So now I have an expression that will help me solve this problem for C. So 1500 joules on top divided by 275 grams times my change in temperature, which is 30. So I get for C 164 after a round, and then my unit I just look up here is joules divided by grams times degrees Celsius, which I can check my notes is the unit for specific heat. So that checks out.